Hello dear students, welcome to the channel Pen and Paper Chemistry on YouTube. With this video, we continue with the topic of carbon and its compounds, and this is part number 2. In part number 1, I've already introduced to you the unique property of carbon and which is called as tetravalency. Today, we are going to continue with this topic and talk about something more. But before we do that, please don't forget the pen and the paper, the same one that you used for video 1, so that you have notes for offline reference. In video 1, we learnt that carbon is able to form 4 bonds with other atoms, and those can either be single bonds as depicted, or they can be double bonds, or they can be triple bonds as well. But if you see group 14 in the periodic table, yes, you can refer to it: carbon, silicon, germanium, tin, lead. So if you see even silicon, it is able to show tetravalency. Silicon is able to form 4 bonds. So why don't you have a large number of compounds of silicon as well? We don't see a large number of compounds of silicon. What is it about carbon other than the tetravalency which enables it to form a large number of compounds? Catenation. What is catenation? The size of carbon is just right enough that it can form bonds with other carbon atoms, long chains. We all use something which is called as polythene, very common. This has got almost thousands of carbon atoms arranged or attached in a chain, which makes it a polythene. What is the basis of this word? We will understand later. But for now, just understand that carbon is able to form long chains without breaking, not just straight chains. It is able to make chains which are branched. We can have chains like this. It is able to form chains which have a ring. Now, all these structures that I am drawing may feel a little weird to you. Don't worry. Just keep watching. Promise by the end of 3rd, 4th video, you will be very comfortable with this topic. Now you notice the dashes that I have put here while speaking. What is this? So these are the remaining bonds. We studied earlier that carbon is able to form 4 bonds. So 1 bond, 2 bond, 3 bond, that means there's a 4th bond in the case of carbon which is still available. Look at this carbon, it has formed only 1 friendship. 1, 2, 3 more left. Look at this carbon, it has formed 1 and 2. So that means 2 more bonds are left for it to form. Similarly, look at this carbon, 1, 2, 3 and 4. Now that 4th and 3rd bond can be with hydrogen, chlorine, any other atom. The details of which we will do later. Also observe, see, I have attached 6 carbon atoms in the form of a ring. But their valencies, their friendships are not yet complete. Now this carbon can form 2 other bonds. This carbon will form 2 other bonds. This carbon will form 2 other bonds. See, their 4 bonds have to be completed, a tetravalency. So the size of carbon is just right enough for it to bond with other carbon atoms or other atoms in long chains without breaking. This property is what we call as catenation, ability to form long chains, branch chains, ring, in order to form a large number of molecules. That means catenation and tetravalency. So these are the two things which you have understood and which you have learnt in this topic, which enable it to form a large number of compounds. So you see, this is a straight chain, this is a branched chain, this is what we call as a cyclic structure. I haven't yet shown structures where there's a possibility of double or triple bonds between the carbon atoms. So if you see, there are endless properties or endless ways in which carbon atoms can join with each other. So tetravalency, catenation. Please make a note of this. You definitely are asked the definition, the explanation of it, and it is actually the very basis of a new branch of chemistry which is called as organic chemistry. Chemistry involving the study of organic compounds. Now, where does the word organic come from? Organic means living. We all know about organic farming these days, organic foods, organic products in the supermarkets. So organic is living. That means something which is made out of living things, or something which is a part of all living things. So organic is all living things are made up of organic compounds. So we need to define organic compounds, correct? So organic compounds are nothing but compounds of carbon with other elements. What can be those other elements? Hydrogen, oxygen, nitrogen, sulfur, halogens, etc. In fact, we have metals also which form compounds with carbon, although they are not many, but yes, there are metals as well which form compounds with carbon, and they are all studied as a separate branch because there are immense possibilities of the way carbon can join with each other and with other atoms. That is why we needed to have a separate study for each one of these, and their behavior and their chemical properties are very much different from compounds like magnesium chloride, sodium hydroxide. Now these are all ionic compounds, and the behavior of organic compounds is very, very different from these compounds. That is why, and there are a large number of such compounds existing in nature. So we needed a separate branch known as organic chemistry. Now a question arises here: are there compounds of carbon which are not considered organic compounds? Yes. You have studied carbon monoxide, carbon dioxide, carbonates, bicarbonates in your previous lessons. These are compounds of carbon but are not considered organic compounds because their behavior is very different from those of organic compounds. And in fact, it was much later that we realized that we needed organic chemistry as a separate branch. Initially we did not know, because we all know that the percentage of carbon dioxide existing in nature is approximately 0.03%. And it is just 0.02% in the Earth's crust. In the Earth's crust, it is present in the form of carbonates, bicarbonates, and so on. So we never imagined that there would be so many compounds of carbon existing in nature. So you see, chemistry is still developing. It's a branch of science where we are still researching. We are knowing about the behavior of substances. So carbon monoxide, carbon dioxide, carbonates, bicarbonates still continue to be studied under inorganic chemistry. The behavior of such compounds also is very different from those of the organic compounds. Do all organic compounds form the living system? No, not necessarily. It's not that each and every organic compound is formed in our body or is present in the living things. In fact, there are approximately 3 million organic compounds known so far. So, do you think all 3 million are being studied as part of the living system only? No. They could be associated, but yes, we are made up of organic compounds, fats, proteins, carbohydrates. So these are all organic compounds, the details of which you will do in biology. A very interesting question arises here. What makes it possible only for carbon? You see, under group 14 we have other elements as well: silicon, germanium, tin, lead. In fact, there are elements after this, there are elements before this. I am talking about group 14 in the periodic table. As students of chemistry, you should have a periodic table pasted close to your study area so that you can refer to it. So let's come back to our question. What makes it possible for carbon to show the property of catenation, that is forming long chains without breaking, while other elements of the group are not able to do so? In fact, silicon, it does form, but beyond the 7th or the 8th atom, the chains is not able to stretch beyond that. Whereas if you remember, I've mentioned to you that carbon is able to connect in the form of thousands of carbon atoms connected with each other. Look at the size. Now, when you will study the periodic table, you will realize that the size of carbon atom is the best. This carbon atom is actually in between the bigger atoms, which are the alkalis on the left hand side, the alkali and the alkaline earth metals on the left hand side, and the smaller atoms on the right hand side. The size of carbon is just large enough to hold 4 atoms around itself, so that the pull that it exerts to the shared pair of electrons is strong enough, and these shared pair of electrons do not move away from in between the atoms which are involved in sharing of electrons. Now, these atoms, so far I have been writing only hydrogen. These atoms can be other than hydrogen. So, for example, I could have chlorine also as the atom CCl. Okay, question to you. Would you call this compound as a hydrocarbon? Think, what did we define hydrocarbon as? Yes, a compound made up of only carbon and hydrogen. But would you call, so is this a hydrocarbon? No, this is not a hydrocarbon. But is this an organic compound? Yes, this is definitely an organic compound. The second reason which explains why carbon is able to form or show the property of catenation is the strength of the carbon-carbon bond. So here we have spoken about carbon being able to hold the electrons in the bonds between the two atoms involved in sharing of electrons. Second is the strength. So when carbon is forming long chains, these bonds do not easily break down. It is not easy to break down these bonds. The strength of this bond, the carbon-carbon bond, the bond between the two carbon atoms, is just right enough to hold the long chains in place. A very interesting question that I want to put to you. On what basis can we say that carbon undergoes covalent bonding? So you remember that I explained to you that carbon doesn't undergo ionic bonding, it undergoes covalent bonding. Now this is theory. What are the practical observations which prove that my assumption regarding covalency of carbon compounds are there? So you have to tell me what practical observations are there which support that carbon undergoes covalent bonding and not ionic bonding, or in other words, organic compounds are covalent compounds and not ionic compounds. Think about this. I will give you the answer, but in the meantime you think about this. You will need your knowledge about ionic and covalent compounds to answer this question. Let us now start applying our knowledge to making organic compounds, drawing the structure of organic compounds on our own. Remember that when we are drawing a single line between two atoms, it means a single covalent bond. Covalent is sharing, single means one pair. Whenever it's a single bond, that means there's one pair of electrons being shared between the two atoms. Double bond, double covalent bond would be shown by two lines drawn between the atoms. That means how many electrons? 1, 2, 3, 4. That means 4 electrons. How many pairs? Yes, 2 pairs of electrons being shared. How about triple covalent bond? C, triple bond C. Count. How many electrons are being shared? Yes, 3 pairs, and that makes a total of 6 electrons being shared. And what is this bond called as? Triple covalent bond. Now, what is the simplest compound of carbon that we know? Carbon bonded to the simplest atom, the smallest atom that we know, and that is hydrogen. That's the simplest organic compound. What is the name of this compound? It is known as methane. You see carbon forming 4 bonds. What is the maximum number of bonds that carbon can form and has to form is 4. Either it can be with same atom or it can be different. So we have the simplest organic compound, methane. It was earlier known as marsh gas because it used to be found in marshy areas. Okay, let's try and make more organic compounds. How about if 2 carbon atoms are joined to each other? Now look at how many hydrogen are you going to attach. So there's 1, 2, 3, because a 4th bond is already occupied with the carbon. How many such lines do we have to draw? 1, 2, 3. And this is hydrogen. H, H, H and H. If we take the first compound, I can write its formula as 1 carbon and 4 hydrogen. Remember, the H has to be capital. It stands for hydrogen, atom hydrogen. What about the second compound? C2H6. Count 1, 2 and count the hydrogen, 3 here and 3 here, C2H6. Okay, what about if 3 carbon atoms make a friendship? So they are attached by single covalent bond. Now how many hydrogen are you going to put? Pause the video, put the hydrogen atoms and tell me the formula. Write the formula in your notebook and then check whether you get it right or not. It is interesting when you go for tuitions as well. So if you want to save on that money, why not learn with me as you would from a live tutor? Yes, so we have H, H and H. H and H. 1, 2, 3. C3. What am I writing? C3. H. How many are there? 1, 2, 3, 4, 5, 6, 7 and 8. C3H8. So this way we can build a large number of organic compounds, and you see these organic compounds, it's not just that I am making it on paper, they do exist in nature. So we have methane, ethane, propane. Oh my God, where are those words coming from? Don't worry, I won't make you memorize them. It's very easy. There is a system to it about which we will talk later. In the meantime, continue with what we are doing. Okay, what is the unique thing that you notice about all these molecules? What are the atoms that these molecules are made up of? Yes, they are all made up of hydrogen and carbon. Hydrogen and carbon. So these compounds are known as hydrocarbons. Compounds which are made up of only carbon and hydrogen are known as hydrocarbons. You can note down the definition. Your notes will be ready. You can refer to them later on as well. So if you see this lot of compounds, so CH4, C2H6, C3H8, let me write them again. CH4, C2H6, C3H8. What is the difference in the number of carbon atoms between the two compounds that you see over here, CH4 and C2H6? Yes, there's a difference of 1 carbon and there is a difference of 2 hydrogen over here. Okay, what is the difference in the number of carbon atoms and hydrogen atoms between the second and the third compound? Okay, 1 carbon and 2 hydrogen. So can you tell me the fourth compound without drawing the structure? What do you have to add to the third compound in order to get the fourth one? Yes, C4H10. Similarly, can you give me the fifth compound? C5H12. See, you are becoming so intelligent. You are already grasping organic chemistry. Every time when I move from one member to the next, I'm not talking about one member to the third or the fifth one. I'm talking about successive members. Successive means coming one after the other. So when you move from one member to the next, you are adding CH2 to the previous molecule in order to get the next one. Isn't it an interesting trend? So the question that I had put to you was, what do you feel is the difference between the two molecules? Yes, they are differing by the CH2 group. And for those who are familiar with the atomic numbers and mass numbers, carbon, the mass number is 12. Hydrogen, the mass number is 1. So that means each of these member differs from the previous one by a mass of 14U. In case you are not familiar with this, don't worry. When you do the atomic mass and the molecular mass, you will be able to understand this. For now, let's move on to the next bit. What if there is a double bond between the two carbon atoms? Now, for a double bond, for sure, you need 2 carbon atoms. Can I have double bond only with a single carbon atom? No. A carbon atom cannot form 2 friendships with itself. It needs to form 2 friendships with another carbon atom or with maybe another atom. But since presently I am only talking about hydrocarbons, we will limit ourselves to just carbon and hydrogen. Now draw the dashes to show the hydrogen atoms. How many? Be careful. carbon has already formed 2 bonds with another carbon. Now how many are left? Yes, there is a hydrogen, there is a hydrogen left. There is a hydrogen, there is a hydrogen left. You see, I have formed another compound. The first compound with 2 carbon atoms had only single bond between the 2 carbon atoms. This is a new compound that we have formed where there is double bond between the 2 carbon atoms. Okay, what if I have 1, 2 and 3 and there's a double bond? Now how many hydrogen are you going to put? Okay, 1, 2 and 1 and 2? No? Why? Oh yes, because if you see carefully, my carbon has already formed 1, 2 and 3. 3 bonds are already there, so it can only form one more bond, and that is the single dash here. What about this carbon here? Yes, it is going to be 1, 2 and 3. So H, H and H, and then if we have a hydrogen, we have a hydrogen, we have a hydrogen. Okay, next question. What is the difference in the atoms between these 2 compounds? Okay, so they differ in 1 carbon. And how many hydrogen? Look carefully. So here I had C2H4, whereas here I have C3H. How many do I have? Yes, 6. So what is the difference in the number of carbon? Yes, 1. And the number of hydrogen? CH2. Oh, that's so interesting. Okay, what if you have to build the next compound? What do? Can you give me the formula of the next compound directly? Yes, that will be C4H8. Isn't it interesting? But we will have to name them differently so that I do not confuse this compound with this one. Here I have a set of compounds where there is only single bond between the carbon atoms. You see over here? And these type of compounds where there is only single bond between them are known as saturated carbon atoms, saturated compounds. Saturated means their valencies are all singly occupied. They are fully satisfied. Only single bond between the carbon atoms. Understand the word that I am saying, only single bond between carbon atoms. I am not saying single bond between carbon and the other atoms. Why am I stressing on this word? I will explain to you later. Okay, now you try. Try forming compounds, 3 compounds wherein there is a triple bond between the 2 carbon atoms. Okay, just 1 triple bond. We don't want to complicate. That's why I didn't put double bonds. You know, 1 carbon forming 4 bonds with other carbon atoms, it becomes very painful. It becomes very difficult also for the carbon to hold. So that is why we are just going to stick to 1 double bond or 1 triple bond. Form the structure. Here, go ahead, give me the formula. Try this. When you try, you will think for yourself. You will enjoy the topic more. Okay, should I give you the answer? Okay, if you've got this. So C2H2. And how about here? Okay, 1 hydrogen. And should I put 1 hydrogen here? No? Why? Yes, because 3 bonds here and 1 bond here. It does not need to form any more bonds. And what about this carbon atom? Yes, this will go on to form 3 more bonds. So C3H4. Okay. Now let's see the difference between the number of carbon atoms. 1. Number of hydrogen atoms, 2. So can you give me the formula of the next compound in the series? Yes, it will be C4H8. H6. You just have to add CH2 to it. So if you see, you've done another class of compounds wherein there is a triple bond between the carbon atoms. We are going to classify the compounds as saturated and unsaturated. So how will you define saturated compounds? We did it earlier. That is compounds, more specifically organic compounds. Organic compounds in which the carbon atoms, yes, I am also writing, please you also write it down, are attached or more specifically bonded by single covalent bond. You see the importance and the relevance of each of these words that I am using. Single, that is, we drew only single dash between the carbon atoms, single covalent bond. Organic compounds in which the carbon atoms are bonded by single covalent bond are known as saturated compounds. What about unsaturated? Organic compounds, you can match the definition that you have written. Organic compounds in which there is double or triple covalent bond between the carbon atoms are known as unsaturated. Please make sure that you value or see the relevance of each and every word that you are writing over here. These are called as key terms and which are very, very essential when you are defining something in chemistry. In the next video, I shall be introducing a new term to you, that is homologous series. So do stay connected. I look forward to your comments, smileys and your feedback on the videos. Happy learning to all of you. Do subscribe for more videos in chemistry and don't forget to share the channel with friends and classmates. See you in the next video.